Hello everyone, I welcome you all to the lecture series of alcohols, phenols and ethers. So this lecture is going to have a discussion about the daily uses of alcohols, phenols and ethers and the nomenclature and the isomerism and the methods of preparation along with physical and chemical properties that all we will be discussing in the lecture series of alcohol, phenols and ethers. So let's begin with nomenclature. We can mention first their daily life uses. It's like ethanol. Ethanol is something used in our day-to-day life in alcoholic drinks. It's used in cough syrups. It's having various other applications too. It is used as a solvent, and it's also used for polishing wood surfaces. Okay, so there are different uses of ethanol, and it is one of the compound which causes addiction to, so it's used as alcoholic drinks must be avoided. Next to this is glycerol. Glycerol is having its cosmetic applications, that's propane 1,2,3 triol, we will discuss also. Next to this is phenol. Phenol is used to prepare antiseptic and disinfectants. Next to phenol is ethers. They are used to prepare uh, the fragrant compounds, like they are used to give fragrances. They are highly volatile basically. So that was a brief discussion about the uses of alcohols, phenols and ethers in our day-to-day life. Let's start our lecture with nomenclature. So first is methanol, is also known as geron or carbinol. Next to this is cinnamyl alcohol. So cinnamyl alcohol is benzene ring, then CH, double bond CH, CH2OH. Okay, and if it's a CH2OH in the place of CH2OH, if it's a CHO, then it will be named as cinnamaldehyde, and if it's a COOH, then it will be cinnamic acid. Next to this is crotonyl alcohol. This is CH3 CH3 CH double bond CH CH2OH. So if in place of CH2OH it's a CHO, then it's crotonaldehyde, and if it's a COOH, then it's crotonic acid. Next to this is glycerol. Glycerol is nothing different from propane 1,2,3 triol, and next to this is ethylene glycol. That's an antifreeze, CH2OH, CH2OH. Okay, uh, it basically lowers the freezing point of water, which is used in radiators. Next to this is active amyl alcohol. This is 2-methyl butanol. Next to this is phenol and its derivatives. So phenol, catechol, resorcinol, quinol. So catechol is 2-hydroxyphenol or 1,2-dihydroxybenzene. Hydroxybenzene is only phenol. Uh, resorcinol, that's 3-hydroxyphenol or 1,3-dihydroxybenzene. Next to this is quinol, 4-hydroxyphenol or 1,4-dihydroxybenzene. Next to this is hydroxyquinol, that's 2,4-dihydroxyphenol, or you can name it as 1,2,4-trihydroxybenzene. Next to this is fluoroglucinol, that's 1,3,5 uh, trihydroxybenzene or 3,5-dihydroxyphenol. Next to this is ethers, anisole, phenitol, benzyl vinyl ether or benzyl oxyethene. These are example of various ethers. So anisole, if benzene ring is having OCH3 group or it, that's methoxybenzene, that is known as anisole. If it's having OC2H5 group over it, that's ethoxybenzene, that's phenitol. Next to this is benzyl vinyl ether, that's benzyl oxyethene. Next to this is 4-ethoxynitrobenzene. Let's come up classification. So classification on the basis of number of OH group presents, that's monohydric alcohols, dihydric alcohols and trihydric alcohol. Monohydric alcohol is ethanol, CH3CH2OH, dihydric alcohol ethylene glycol, CH2OH, CH2OH, and trihydric alcohol is glycerol, that is CH3CHOH, CH2OH, CHOH, CH2OH, that's glycerol. Next classification. So this was the first classification, that's on the basis of number of OH groups present. If it's one OH group, then it's monohydric, two OH groups dihydric, three OH groups trihydric. आई होप समझ में आया होगा ये. And nomenclature we can discuss a lot, but we have briefed it here only. Next classification is if carbon is sp3 hybridized or sp2 hybridized. If it's sp3 hybridized, then the carbon can be primary, secondary or tertiary. The example we have taken isomers of butanol. Butanol, butane 2-ol, 2-methyl propane 2-ol. So what's basically butanol is butyl alcohol, and butane 2-ol's common name is secondary butyl alcohol. Next to this is 2-methyl propanol and its common name is tert butyl alcohol. Next to this is vinylic alcohol. If the carbon is sp2 hybridized and the OH group is attached with, that's CH2 double bond CHOH, that's vinylic alcohol. Or phenol is also something we can mention here. So that's all about it. Now let's move ahead to the preparation of alcohols, preparation part. So that was a brief about nomenclature and classification. Next is preparation of alcohols. So first is by acid reflux followed by hydrolysis. Okay, so this is R CH double bond CH2. It's reacted with H2SO4 and then H2O. Then the major product formed here is the secondary alcohol along with the minor product as primary alcohol. So why this product is major here? The answer lies in the mechanism of the reaction. So basically we will see here the carbocation will be formed as an intermediate in between the reaction. So more stable the intermediate, more faster will be the reaction. So the carbocation formed, the secondary carbocation if formed is more stable as compared to the primary carbocation. That's why it's hmm, we can say the secondary alcohol is formed as a major product. Okay, so let's have a look at its mechanism. Okay, so let's have a look at the hypothetical pathway by which the reaction is getting proceed. We are explaining the reaction. So the step one here we are having is protonation of attack of H positive or alkene, attack of electrophile you can say. So it's first of all, what is the electrophile here? That's H3O positive. So whatever the alkene is, the electrophile will attack over it. And there will be addition of H plus over this electron cloud. So this is a double bond, which is basically a pi electron cloud. So this pi electron cloud will attract this positive charge, and hence H plus will get attached to one of the carbon. So there are now two possibilities. Either H plus can get attached to CH2 group or the CH group. If it's get attached, uh, if it get attached to the CH2 carbon, then it becomes CH3, and the carbocation formed is secondary carbocation. Next to this is if the H plus get attached to here, then it's RCH2, CH2 positive, then it's primary carbocation. The primary carbocation being less stable, the reaction will not proceed through this, and the secondary carbocation being more stable, the reaction will definitely proceed through this only. Next to this is step 2, that is attack of nucleophile, or we can write this step as nucleophilic attack of H2O on carbocation form. So how the reaction is getting proceeded, so this is getting proceeded because the H3O positive is getting attracted by the pi electron cloud of the double bond, and hence it's forming the carbocation which is secondary in nature. Then step number 2 is nucleophilic attack of H2 on the carbocation formed. This is CH3, C positive, CH3, CH3. So it will form. positive. Okay. Now step 3, you can mention as deprotonation. So that will form alcohol. So H plus used earlier in the reaction gets we are getting it back as H3O positive. Okay, in the solution the H plus exists as H3O positive only. So this is secondary alcohol. This is formed as a major product, and the primary alcohol is formed as a minor product. So that's how the reaction is getting proceeded. So that was all about the acid reflux followed by hydrolysis or acid catalyzed hydrolysis of alcohols. So in this we are just taking H2SO4 in the presence of H2. We are just and the major product formed here is secondary alcohol. Okay. Next to this is hydroboration oxidation reaction from alkenes only. Next to this is hydroboration oxidation reaction. What's hydroboration oxidation reaction is? The reagent we are using here is RCH double bond CH2 alkane is getting reacted with B2H6 in the presence of THF that's used as solvent, and then it is further reacted with H2O2 in the presence of OH negative. So the product formed here is anti-MKL product. So that's RCH2 CH2OH. Okay, that's a single product formed here. Okay, no major, no minor. How this happens? Let's have a look at its mechanism. So what happens is the trialkyl borate is formed here, which further reacts with H2O2 to form boric acid along with alcohol. So let's have a look at it how it happens. RCH double bond CH2. So that's this double bond is something which is electron rich, having a pi electron cloud. Then BH3, that's electron deficient in nature and will attack over this pi electron cloud, and this will form RCH CH2 BH2 and one nitrogen here. So what is formed here is R CH2 CH2 BH2. Next to this, it further react with RCH double bond CH2. Then it forms dialkyl borate, that's RCH2 CH2 all twice BH. It further reacts with RCH double bond CH2. Then it forms trialkyl borate RCH2 CH2 all thrice B, trialkyl borate. So that's something finally formed here. And this trialkyl borate will further react with H2O2 in the presence of OH negative, which will form R CH2 CH2 OH plus H3BO3. That's the final product. Okay, so this is something known as syn addition. because the both H positive and BH2 are getting added from same side. This is known as syn addition. Okay, and the both are getting added from the same side, and that's because of this complex form. This complex is known as pi complex, and the addition is known as syn addition. So S3BO3, that's nothing but BOH whole thrice. So anti-MKR product is formed as a major product here. Second is from alkyl halides. Okay, that's by their hydrolysis. And the reagent used here is aqueous KOH. So let's see how it happens. RCH2X reacts with aqueous KOH, and this forms RCH2OH. Okay, and if this is primary or secondary, the reaction will proceed by SN2 mechanism. And if it's tertiary, then the reaction will proceed by SN1 mechanism. The product will be same, but we'll consider it getting proceeded by SN1 mechanism. So our racemic mixture will be formed here if the carbon is chiral, and we will say a inverted product is formed here. Inversion is something will happen here. Okay, so if the reaction is getting proceeded by SN2 mechanism, inversion will happen, and if it's proceeding by SN1 mechanism, then racemic mixture is formed. So that's about from alkyl halides. That तो we know अगर SN1 से हो रहा है तो क्या होगा, and if it's proceeding by SN2, then what will happen. Next to this is from carbonyl compound. Let's have a look at how the alcohols are prepared from carbonyl compound. So first is by reduction of aldehydes and ketones. Definitely we will reduce them by reduction of aldehydes and ketones. So what they will yield on reduction? Aldehydes on reduction will yield primary alcohol, and ketones on reduction will yield secondary alcohols. This is CH3OH, RC double bond OH will give RCH2OH. So these are primary alcohol. Next to this is ketone. So this is secondary alcohol. Okay. The reagents used here will be platinum in the presence of hydrogen, LiLH4 or NaBH4. Okay. Next to this is by Grignard's reagent. Okay, so these I have written in the decreasing order of their reducing power. The most reducing is platinum in the presence of hydrogen. Next LiLH4, NaBH4. LiLH4 cannot reduce double bond and triple bond. They cannot be reduced with the help of LiLH4. And NaBH4 cannot reduce acids and their derivatives like carboxylic acid, ester, and uh, amides. They basically cannot be reduced with the help of NaBH4. With the help of NaBH4, but we can reduce one of the acid derivative, that is carbonyl chloride. That so we can reduce with the help of NaBH4. These carboxylic acid, ester, amide, these we cannot reduce with the help of NaBH4. And double bond and triple bonds cannot be reduced with the help of LiLH4 as well as NaBH4. And platinum in the presence of hydrogen. So that's a strong reducing agent that can reduce it all. Okay. So any of the reducing agent we can use. So if it's aldehyde, the primary alcohol, and if it's ketone, then secondary alcohol will be formed. Next is by Grignard's reagent. First was by reduction, second is by Grignard's reagent. Okay, if the Grignard's reagent is reacted with formaldehyde, like, then what is formed is primary alcohol. Its hydrolysis will yield primary alcohol. Next to this is ketone. So this will form ketone hydrolysis will form, that is tertiary alcohol. So basically formaldehyde will yield you primary alcohol, ketone will yield you tertiary alcohol, and a normal aldehyde will yield us secondary alcohol. So this is secondary alcohol. Okay, this is secondary alcohol, and the earlier one was tertiary alcohol, and that's primary alcohol. So by Grignard reagent, we can prepare all primary, secondary, tertiary alcohol, but by reduction, we can prepare primary and secondary alcohol only. With the help of Grignard reagent, we can prepare primary, secondary, tertiary alcohol. If it's formaldehyde, then what is formed is primary alcohol. If it's aldehyde, then what is formed is secondary alcohol. And if it's ketone, then what is formed is tertiary alcohol. Next is from carboxylic acids. R C double bond OH reacts with LiLH4 followed by hydrolysis. This will yield RCH2OH. If it's ester, then it will yield RCH2OH plus R dash OH. We can use LiLH for H3O positive also here. So that was about preparation of alcohols. So either we can prepare them from alkenes or aldehydes or ketones or alkyl halides. So for preparing them from alkenes, we have acid catalyzed mechanism. Next is the hydroboration oxidation reaction. Then one more reaction we are having, that is for MKR addition only, but in that rearrangement does not occur, and that is like that reaction is oxymercuration and demercuration reaction. That also we can write here. Okay, in the from alkenes. From alkenes we have wrote two reactions. One is acidic hydrolysis and second one is hydroboration oxidation reaction. Third one we can write here is oxymercuration demercuration. Okay, so what is oxymercuration demercuration? It just yield MKR product without any rearrangement. No carbocation is formed here. The reagents used here are RCS double bond CH2, that's reacted with CH3 double O whole twice dimercurate diacetate in the presence of, then it's further reacted with NaBH4. The presence of H. So that's how the reaction proceeds and the product formed is MKR product. Okay, so this is also one of the chemical reaction we can write oxymercuration demercuration. Okay, and next to this was the hydrolysis of alkyl halides and then reduction of carbonyl compound, and by reacting the carbonyl compounds with Grignard's reagent. Let's now come to the preparation of phenols. Let us have a look at how they are prepared. First is the Dawes process. Dawes process. This is one of the method we have studied in haloalkanes and haloarenes also. So what's this? This just chlorobenzene that is reacted with NaOH at extreme conditions, that's 623 Kelvin and 300 atm pressure, or you can write it as 350 degrees Celsius nearly, or 300 atm pressure. And the formed product here is sodium phenoxide, which on hydrolysis yields phenol. One thing we have to remember here is sometimes students forget this. Okay, so when it's only mentioning NaOH and it's not just hydrolyzing the reactant, it's not mentioning the hydrolysis part. So what we have to form here is sodium phenoxide. Next to this is from Diazonium salt, diazonium salt. What is diazonium salt? That's benzene diazonium chloride, benzene and triple bond N positive, Cl negative, which is hydrolyzed simply, and it will give you phenol along with some nitrogen and HCl. Got it? Third one is from benzene sulfonic acid. From benzene sulfonic acid. Okay, so let's have a look at how it will yield phenol. What is benzene sulfonic acid? Benzene having SO3H. This is something known as benzene sulfonic acid. Let's react it with NaOH, and it will again form sodium phenoxide, similar to Dow's process, and which is again hydrolyzed. Okay, as we have done earlier in both the reactions, and it will form phenol. See, in all the three above reactions, we have hydrolyzed something that is yielding phenol. Fourth one is from cumene. What is cumene? That's isopropyl benzene. What is cumene? That's isopropyl benzene. What's cumene? That's isopropyl benzene. So isopropyl benzene, when is reacted with O2 and heated, then it yields OOH. Then it forms peroxide of isopropyl benzene, that is peroxycumene, which on hydrolysis will yield phenol plus acetone. Acetone is formed as a byproduct here, but this byproduct is something which decides importance of this chemical reaction. It is a major solvent used in industry, and it is having various other uses, like in cosmetics also it is used. So it is of great industrial importance basically. So if an industry needs to prepare phenol, it's also preparing a substance which is of great industrial importance, and that's acetone. So this method is very much used for the preparation of phenol. Why? Because acetone is formed as a byproduct here. So this is industrial method of preparation of phenol. So in all the four reactions, we have used the hydrolysis. Okay, we have hydrolyzed something that's yielding phenol. In the first, we have hydrolyzed sodium phenoxide, which was prepared by the reaction of chlorobenzene with NaOH at 623 Kelvin and 300 atm. That's Dow's process. In the second reaction, we have hydrolyzed diazonium salt. In the third reaction, again we have hydrolyzed sodium phenoxide, which was prepared by sulfonic acid, which was reacted with NaOH. And next to this, we have hydrolyzed the uh, peroxycumene, which is again yielding phenol plus acetone. Okay, so these are the four reactions for preparing phenol. Let's come to the physical properties of alcohols and phenols. They are not much, but whatever they are, let's discuss them. Physical properties. This chapter we are discussing in context to the NCRT. Okay, we are just having a look at the important things from this chapter. First is polarity. The molecules are polar in nature. Okay, the alcohol is polar in nature. Second one, it's protic. So it's something loose H plus. So they are used as protic, polar protic solvents too. Next is boiling point is greater than corresponding organic compounds except carboxylic acids. So its boiling point is greater than amines also because it is having a stronger hydrogen bonding as compared to amines. Okay, so that's something about physical properties and other things will remain same like boiling point is directly proportional to molecular weight. Boiling point is inversely proportional to branching. So these are the different things which will remain same. Next, it's a solubility. We will talk about solubility, then it's soluble in alcohol, water, and solubility is inversely proportional to size of hydrophobic part. Hydrophobic part. Okay, and one more thing, it's soluble in water. So that's done for physical properties. We will limit our discussion here only for physical properties. Next is chemical properties. In the chemical properties, while discussing them, we have classified the chemical reactions into two groups. This is ROH bond. This bond either can be broken, either this bond can be broken. So first we will study the reactions which will explain the acidity of alcohol when this bond is broken. Okay. So the first thing is reaction with metals. If I will talk about reaction with metals, then the nearly all alcohols react with metals to yield like CH3C, CH3. Tert butyl alcohol when reacted with aluminium, it will yield CH3, C, CH3, CH3, O whole thrice Al. Tributoxy aluminium along with 3 hydrogen, 2 molecules of. Okay, next to this is CH3, CH2OH reacted with Na. This will form sodium ethoxide plus H2 gas. If phenol is reacted with sodium, then it will also do the same. Sodium phenoxide plus hydrogen gas. Next to this, if they are reacted with NaOH, if phenol is reacted with NaOH, it can yield sodium phenoxide plus water. But if alcohols are reacted with NaOH, then there is no reaction. Okay, this we have to remember. Next to this is acidity of alcohols. Okay. So acidity of alcohols we will leave it for next lecture. So our lecture we will limit this up to here only. So thanks for watching the whole video. I hope you liked it. Have a good day. Bye bye.